Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is set 3 of 5 good problems on the topic of exponential miscellaneous equation of exponents. This is from the chapter of exponents. If you have not watched the set 1 and set 2 solving of 5 good problems on the same topic, then I strongly suggest and request that you please watch those videos also. You will have a practice of solving good problems. So this video is part of the playlist Maths 8 Hot. Hot HOT stands for high order thinking, where I come up with relatively harder problems based on the topics and chapters as and when they are completed in the other playlist, that is CBSE Maths 8 RS Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 5 good problems of set 3 on the topic of miscellaneous equation of exponents. Okay, so I have the set of 5 good problems on the left hand side. The link of the PDF of the 5 good problems will be there in the description below. As always, try to solve these problems in 30 minutes, taking approximately 6 minutes per question. I will be solving these problems in one way based on my understanding and knowledge, but please note that there could be multiple ways of solving a mathematical problem. Always stick to the method that is most comfortable and understandable to you. Okay. So let's get started in solving the problems. Question number 1. So it is given that 5 to the power x is equal to 125. It is given 6 to the power y is equal to 36, and it is given 7 to the power z is equal to 7. Then we have to find the value of x to the power y to the power z. Now okay, now first of all, what is this expression? What is this exponential term? It is very crucial that you understand what exactly it means. It means the base is x is raised to the power, and that power is again an exponential term, and that exponential term is base is x and x is raised to the power, and that power is again an exponential term where the base is y and the power is z. So z is the power of y, and y to the power z is the power of x, that is the second x, and for this entire exponential term, the base is x and its power is x to the power y to the power z. Okay. Now this problem is relatively simple because we can see we are given 3 equation, and from these 3 equation we can easily find out the values of x, y and z, because 5 to the power x is equal to 125. Now 125 can easily be expressed as a power of 5. 125 is 5 cube. So clearly we can say that since 5 to the power x is equal to 5 cube, base is same 5, so we can equate the powers and we get x is equal to 3. So we got x is equal to 3. Similarly, 6 to the power y is given as 36, and 36 is equal to 6 square. So we can say that if 6 to the power y is equal to 6 square, we can equate the powers, that is we have 5 to the y is equal to 2. The concept is that if you have x to the power m is equal to x to the power n, where x is a non-zero rational number, this will imply that m will be equal to n. Okay, so we have y is equal to 2, and lastly we have 7 to the power z is equal to 7. 7 when expressed in the exponential term, it will be 7 to the power 1. Because we know that any non-zero rational number when raised to the power 1, it is the same number x. Okay, So this implies that z is equal to 1. So we have found the values of x, y and z. Now it is asking what is the value of the given exponential term, the complex exponential term. So x to the power, now x to the power y to the power z becomes, what is x? 3. This is actually 3. 3 to the power 3 to the power y is 2, and y to the power z, and z is 1. This is actually, if you write it in a more readable format, this expression may seem complex, and maybe it is hard to understand. If you just to make it easy to understand, we can rewrite it, rewrite this expression as the base is 3 and its power is again 3 to the power again 2 to the power 1. Okay. So whenever you have this kind of expression where you have multiple levels of powers, not multiple levels of powers, sorry, when you have, when the power is again a power, when the power is again exponential term, you always try to simplify things from the topmost powers. That is, I will first simplify this part, that is 2 to the power 1. So this becomes 3 raised to the power 3 raised to the power, now 2 to the power 1 means 2. Okay. Now I will simplify again from the topmost part, I will simplify this part. So this will become 3 to the power 3 square is 9. 3 square is 9. Okay. Now 3 square is 9. Okay. 2. 3 to the power, it should be 9. We are not having, the base has to be definitely 3, but in the given choices, the powers of 3 are 6 and 4. How come? 6 and 4. Let me see. Oh, sorry. 2, it should be 3 to the power 9. It should be 3 to the power 9 because 3 square, this is 3 square is 9, but there is no 3 to the power 9 in the given choice. Let me quickly check the book from where I have taken this problem, if I have done anything wrong or not. Please give me some time. 5 to the power x is 125, 6 to the power y is 36, and 7, there is 7. Then it is asking x to the power y to the power z is 21. 21. One second, friend, I am quickly checking the textbook. Where is the answer? Oh, the answer is not given. Anyway, I will quickly check whether I have done any calculation mistake or not. So x is definitely 125 is 5 cube. So x is 3 and y is 2. Okay, and z is 1. So it becomes x to the power y to the power z. So 3 to the power what is y? Y is 2 and z is 1. Okay. So this will be 3 to the power 2 to the power 1 is 2 and 3 square is 9. So I think my answer is correct, 3 to the power 9. So this is basically 3 to the power 9, but 3 to the power 9 is not given in the choice. The two choices with base 3 are 3 to the power 6 and 3 to the power 4. I don't know. I'm sorry. My answer did not match with the given choices, and I've checked the textbook from where I've taken this problem. The choices are correct. These are the choices that are given. I don't know. Let me know if I am wrong or whether I have done any calculation mistake or not. I will highly appreciate that. Please feel free to let me know in the comment section. Okay. Let's do the next problem. Problem number 2. Okay, so it is given that x minus y is equal to 3 is given. Then we have to find the value of 5 to the power, and the power is x cube multiplied by 5 to the power minus y cube divided by 5 to the power, the power is 3xy multiplied by x minus y. Now, as you can see, all the choices are some constants. It does not, all the choices do not have x or y. So definitely we have to evaluate or simplify this expression in such a way so that, as you can see, that all the factors, this is a rational term. This whole expression is a rational term where the numerator is a product of two exponential terms. The first term is 5 to the power x cube, and the second factor is 5 to the power minus y cube, and the denominator is again an exponential term, and all the factors are exponential terms with base 5. So I can simplify this whole expression as a single exponential term with base 5, and the power of that exponential term should be such that I can evaluate its value based on the fact that x minus y is equal to 3. Okay, so let's see. Let's do it step by step. So the simplifying this expression is pretty simple. I know that if I simplify the denominator, it will be, I will just add up the power. So it will be 5 to the power x cube minus y cube, and I have in the denominator 5 to the power 3 into xy multiplied by x minus y. Okay, so in the first step I applied the concept of x to the power m multiplied by x to the power n is equal to x to the power m plus n. Now in the second step I see it is of the form x to the power m divided by x to the power n, and this will be equal to x to the power m minus n. So I will now apply this concept, and after further simplifying, it will be 5 to the power, we have x cube minus y cube, this minus 3xy multiplied by x minus y. Now you must be familiar with the algebraic algebraic expressions and identity. I think you know the algebraic identity that x cube minus y cube is equal to x minus y multiplied by x square plus xy plus y square. I hope this algebraic identity you are familiar with already. Okay, so I will use this algebraic identity. So now I can say I will expand x cube minus y cube using the algebraic identity. So this becomes 5 raised to the power x cube minus y cube. I will write it as x minus y multiplied by x square plus xy plus y square, and I have minus 3xy x minus y. Now in the power, concentrate in the power. I have the power is an algebraic expression of x and y where I see it is a subtraction of two algebraic expressions, and both the algebraic expression, the first algebraic expression is this one and the second algebraic expression is this one, and they have a common factor of x minus y. So I will factorize the power taking x minus y as the common factor, and it will be x minus y multiplied by, it will be x square plus xy plus y square minus 3xy. Okay, this is equal to x minus y. Now I will simplify this part, and it will be x square plus y square. I have xy and minus 3xy, which is minus 2xy. Now this part, as you can see, it is in the form of, it is the formula of a minus b whole square, because we know that a minus b whole square is equal to a square. This is also an algebraic identity, a square plus b square minus 2ab. So this becomes equal to 5 to the power is x minus y, and it becomes x minus y whole square. This again is equal to 5 raised to the power x minus y cube. So as you can see, the power is now in terms of x minus y, and we know the value of x minus y is 3. So we can write it as 5 raised to the power, and the power is 3 cube. This is equal to 5 raised to the power is 3 cube. 3 cube is 27. What is wrong? Mine, this I am having 3 to the x minus y whole square 5 to the power 27 I am having, and the choices are 5 by 9, minus 5 by 9, 5 to the power minus 9, 5 to the power minus 9, and 5, and I am having the answer 5 to the power 27 is not at all matching with any of the choices. Let me see if I have done anything wrong or not. X minus y is equal to 3. I will first of all check whether I have again done any mistake in copying the problem or not. This is very bad. Let me quickly check if I have done anything wrong or not. No, the problem is correct. Okay, let me see if I have done any calculation mistake or not. So in the first step, we have 5x cube, 5 to the power x cube, and multiplied by 5 to the power minus y cube. So we will just add up the power, and we have 5 to the power x cube minus y cube. Okay, x cube minus y cube. Okay, and we have in the denominator 5 to the power 3xy multiplied by x minus y. Okay, now in the second step, we are having 5 to the power x cube minus y cube minus 3xy x minus y, and x cube minus y cube we know is using as per algebraic identity, x cube minus y cube is equal to x minus y multiplied by x square plus xy plus y square. Okay, okay. So now we have factorized, we have taken x minus y. After taking x minus y as the factor in the power, we have 5 to the power x minus y multiplied by x square plus xy plus y square minus 3xy. This is fine. So 5 to the power x minus y whole cube, and this is equal to x minus y is given as 3. X minus y is given as 3. So this must be equal to 5 to the power 3 cube. 3 cube is 27. I don't know. I have no idea. 5 to the power 5. Oh, sorry. Anyway, the last choice is 5 to the power 9, but still my answer is coming as 5 to the power 27. Some problem with the textbook from where I have copied all these questions. The choices are not given correctly. Please do let me know if my answer is correct or not, or if I am doing any kind of calculation mistake. Please do let me know in the comment section. I will appreciate that. So first two questions I was not able to match the answer, but I am quite sure my answer is correct as per the given problem. Okay, but I hope you are learning the concept of how we are approaching this kind of problem, applying, and also how we are applying the laws of exponents at every step. Okay, let's see question number 3. Okay, so it is given that 2 to the power a is equal to 4 to the power b is equal to 8 to the power c, and it is given that a b c is equal to 288. Then we have to find a b and c. We have to find a b and c. Oh, okay, we have to find a b and c. Okay. Let's see how do we solve now. Let's see from the given equations what we can get. We have 2 to the power a is equal to 4 to the power b. 4 to the power b. Okay. So this implies now what is 4 to the power b? 4 to the power b, the base 4, I can convert it as a power of 2. So this is 4 is 2 square, and I have 2 square whole raised to the power b, which is equal to 2 to the power twice b. So we have 2 to the power a is equal to 2 to the power twice b. So equating the powers, I get a is equal to twice b. Okay, so this information I got. Okay, now let's see what do we get from 4 to the power b is equal to 8 to the power c. Let's express both the LHS and RHS as a power of 2. So 4 to the power b is nothing but 2 square whole raised to the power b, and 8 to the power c, 8 is 2 cube, and this whole raised to the power c. So this implies, applying the laws of exponents, that is power of power, we get 2 square whole raised to the power b is 2 to the power twice b is equal to 2 to the power thrice c. So now I can equate the power. I have twice b is equal to thrice c. Okay, so a is equal to twice b and twice b is equal to 3c. So what I got is a is equal to twice b is equal to thrice c, and also I know that ABC is equal to 288. Okay, so I hope now it is very simple. You can easily solve the value of we can easily find the value of a, b and c from the fact that a is equal to twice b is equal to thrice c, means that we are given the ratio of the values a, b and c. If you know the ratio of the values of the a, b and c, and also if you know ABC is equal to 288, we can easily find the value of A, B and C from the concept of ratio and proportion. So how do we do? So from the fact that A is equal to twice B is equal to thrice C, let's see what is B and C in terms of A. So B will be equal to A by 2 and C will be equal to A by 3. Now we have ABC is equal to 288. So this implies A, what is B? B is A by 2, and what is C? C is A by 3 is equal to 288. So this implies, if you simplify the LHS is A multiplied by A by 2 multiplied by A by 3. If I simplify this, it becomes A cube by 6 is equal to 288. This implies A cube is equal to 6 multiplied by 288. Now to find A, I have to find, so this implies A will be equal to cube root of 6 multiplied by 288, and we have to now find the cube root of 6 multiplied by 288. Let's factorize. Let's see. So 288. So what is 288? I think it will divide by 6. It has to. 6 is 4, 88. Okay. So 6 is 8. Okay. So this is equal to cube root of, we have 6, and 288 is 6 multiplied by 6 multiplied by 8. Okay. This is equal to cube root of, we can see 3 6. So it will be 6 cube, and 8 we know is 2 cube. So this is equal to cube root of 6 cube multiplied by 2 cube. I can write it as 6 into 12 whole cube. This is equal to 6 into 12. Applying the concept that cube root of x cube, where x is definitely a non-zero rational number, this is always equal to x. So this is equal to 72. So A is 72, and I do not have 72 as the answer. Oh, I did a mistake. So this is 6 cube multiplied by 2 cube is not 6 multiplied by 12 cube, but it is 12 cube. I'm sorry, this is 12 cube. Basically, this is 6 multiplied by 2 whole cube, which is equal to cube root of 12 cube, which is equal to 12. This is equal to 12. So A is 12. Okay, A is 12. So this implies what will be B? We know B is equal to A by 2. B is equal to A by 2 and C is equal to A by 3. So B is equal to A by 2, which is equal to 12 by 2, which is equal to 6. And C is equal to A by 3, which is equal to 12 by 3, which is equal to 4. So this implies A comma B comma C is equal to, what is A? A is 12, and what is B? 6 and 4. So 12 comma 6 comma 4 should be the values of A, B and C, and hence the correct choice is A. A is the correct choice. Okay, let's do this was question number 3. Let's do question number 4. It is given that p to the power q and this whole raised to the power r is equal to tth cube. This is tth cube of p square. Tth cube of p square. Tth cube of x. This is tth cube. Tth root of x. Tth root of x, this is nothing but x to the power 1 by t. Okay. So it is we are given this, then it is asking the value of QRT. It is asking the value of QRT. So basically you can see that both the terms in this equation, this LHS, can be expressed as a in the exponential form with a base p. Also the right hand side is also can be expressed, even though the right hand side is in the radical form, you can see the base is p, because inside the radicand, inside the radical sign, whatever term expression is there inside the radical term, sign, that is known as the radicand. The radicand is p square, and when we apply the tth root, it will be p square whole raised to the power 1 by t. So the right hand side can also be expressed as power of p. Okay, so let's do it. The LHS is nothing but applying the laws of exponents, that is power of a power, it becomes p to the power qr is equal to, the right hand side is nothing but p square, tth root means whatever the radicand raised to the power 1 by t, 1 by t. Okay. Now this can this is equal to, after applying the laws of exponents, that is power of a power, it becomes p raised to the power 2 by t. So now we have p to the power qr is equal to p to the power 2 by t. Both the base are p. So if I equate the power, I have qr is equal to 2 by t, and doing cross multiplication, I have t qr is equal to 2. So the value of QRT is 2, and hence the correct choice is D. D is the correct choice. Let's do the last problem, that is question number 5. If m and n are whole numbers such that m to the power n is equal to 121, then the value of m minus 1 raised to the power n plus 1, we have to find the value of this expression, where it is given that m to the power n is equal to 121 and m and n are whole numbers. M and n are whole numbers, meaning that m and n can be 0 or the natural numbers. Okay. Now are whole numbers. Now definitely, since m to the power n is equal to 121, m cannot be 0, because m cannot be 0. But if the base is 0, then if base is 0, one concept is that 0 to the power m is only defined, this is very important, 0 to the power m, where m is some rational number, it could be integers or fractions or whatever decimals, it's a rational number, is defined only for m not equals to 0. 0 to the power m it will be defined only when m is not equal to 0, and in that case it will be equal to 0. If m is not 0, if m is a non-zero number, a non-zero rational number, then 0 to the power m is always equal to 0. So definitely m is not 0. Okay. Now, so how can we, so and definitely also n is also not 0, because if m is 0, if n is so okay, so this implies we can say this implies that m is not equals to 0, and n is also not equals to 0, because if n is 0, then m to the power 0 will become 1, but it is given that m to the power n is equal to 121. So we have to see what values, so definitely m and n must be natural numbers, and what values can they have, so that m to the power n is equal to 121. So how do we proceed? We have to see how we can express 121 as a exponential term. So how do you, given a number, how do you express a given natural number in the exponential term? You have to definitely do prime factorization. So definitely I can see 11. I know orally that 121 is 11 square. Anyway, so I know that, so this is equal to 11 square. In the exponential form, 11 square is the only possible way of expressing 121. There is no other exponential form. There are no other exponential form that you can that can be used to express 121 in the form m to the power n, where m and n are natural numbers. If m and n are natural numbers, then 11 square is the only possible way. Okay, so this clearly implies that m is equal to 11 and n is equal to 2. So this implies that m minus 1 whole raised to the power n plus 1 is equal to, m is 11, so 11 minus 1. So 11 minus 1 to the power n plus 1, that is 2 plus 1. This is equal to 10 cube. This is equal to 1000. So the correct choice is D. The correct choice is D. Okay, let me quickly once again review the problems 1 and 2 where I could not, where my answer did not match with the given choices. Question 1 and 2. Question 1 and 2. Okay. So question 2 is x minus y is given as 3 and it is asking the value of 5 to the power x cube. Okay, 5 to the power x cube multiplied by 5 to the power minus y cube. Okay, so that becomes the powers get added, 5 to the power x cube minus y cube. Okay, and in the denominator we have 5 to the power 3xy x minus y. So if we simplify, it becomes 5 to the power x cube minus y cube minus 3xy multiplied by x minus y, and x cube minus y cube, I know from the algebraic identity x cube minus y cube will be equal to x minus y multiplied by x square plus xy plus y square. Okay, so it becomes 5 to the power x minus y multiplied by x square plus xy plus y square minus 3xy x minus y. So in the power I will take x minus y as common and I get x minus y and x square plus xy plus y square minus 3xy. Okay, so it becomes x minus y multiplied by x square plus y square minus 2xy, which is x minus y whole square. Okay, and so this is 5 to the power x minus y cube. Okay, and x minus y is 3. So this becomes 5 to the power 3 cube, which is 5 to the power 27. I think my answer is correct. What about this one? Question number 1. It is given that 5 to the power x is 125, which means x will be 3, fine. 6 to the power y is 36, which means y will be 2, fine. And 7 to the power z is 7, which means z is equal to 1. Okay, so we have x, y, z as 3, 2, 1. And the given expression is x to the power y to the power z. So which this is 3 to the power, okay, 2 to the power 1. 2 to the power 1 is 2 to the power 1 is 2. Okay, so this becomes 3 to the power 3 square, which is 3 to the power 9. Yeah, this is fine. I think my answer for question number 1 and 2 is correct. I'm 100% sure. Please do let me know if I am doing any kind of mistake in solving the problem number 1 and 2. I will highly appreciate that. So with this, it brings to an end in solving possibly the last set of 5 good problems on solving miscellaneous exponential equation. I hope these problems will give you a good insight of how to solve this kind of problem using the laws of exponents. If this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. I will end the video here. Thanks for watching, and until the next video, take care and bye.